Ever wondered what would happen if you fell into a black hole? This question, while seemingly outlandish, is one that has intrigued scientists, academics, and space enthusiasts alike. It's not the product of a fantastical imagination or the premise of a hyperbolic science fiction film. Rather, it's a real scientific inquiry that arises from our understanding, or perhaps more accurately, our lack of understanding, of the cosmos. The black hole, that mysterious and enigmatic entity lurking in the vast reaches of our universe, has always been of intense curiosity. What exactly happens when an object or even a person plunges into its inky depths? Would we stay intact, preserving our form as we spiraled downwards? Or would we undergo some form of transformation? Would our bodies stretch into a long, thin strand like a string of spaghetti being pulled at both ends? It's a fascinating, albeit somewhat morbid, line of thought. Given our current understanding of physics and the universe, the answer is captivating. The theory, known as the Spaghettification hypothesis, posits that as you fall into a black hole, you would indeed stretch into a long, thin line resembling a strand of spaghetti. This is due to the immense gravitational pull of the black hole, which tugs at your feet with stronger force than it does at your head, creating a gravitational differential that essentially elongates you. So, there you have it. The answer to a question so bizarre, it could only arise from pondering the mysteries of the cosmos. And the answer? Well, you'd indeed become what we call spaghettified. So what is spaghettification, you ask? Allow me to paint a vivid picture to illustrate this. Imagine, if you will, that you're peacefully and contentedly floating within the vast expanse of the cosmos, completely oblivious to any potential danger. Out of the blue, a black hole materializes. Suddenly you find yourself being inexorably pulled towards its dark, ominous center. This celestial object is no ordinary entity. A black hole's gravitational prowess is of such immense magnitude that it exerts a stronger pull on the part of you that's closer to it than the further away, thereby creating a stretching or spaghettifying effect. This, my friends, marks the beginning of your transformation into a celestial noodle, a cosmic spaghetti, if you will. As you start your involuntary descent towards the black hole, this stretching effect doesn't just maintain its intensity, instead, it amplifies. The difference in the gravitational pull exerted on your head and feet grows so exponentially that an elongation process commences. You start to become more and more attenuated. Your width decreases at an alarming rate while your length starts to increase. This phenomenon signifies the second phase in the process of spaghettification, a phase that sees you transforming into a noodle-like entity of cosmic proportions. The elongation and thinning continue, and as you near the event horizon, the proverbial point of no return, you're no longer the entity you once were. Instead, you're stretched into a long, thin strand, a noodle of cosmic proportions. You've now reached the final stage of spaghettification, a stage that sees you helplessly plunging into the fathomless depths of the black hole. Hold on a minute, though. The ordeal doesn't end here. You're not just stretched, you're also squeezed, compacted. This happens because the powerful gravitational field of the black hole, while stretching you vertically, also compresses you horizontally. So, when all is said and done, you're not just cosmic spaghetti, you're something much more. You're more akin to cosmic angel hair pasta. But what's going on here? Why does a black hole turn you into pasta? This fascinating concept is deeply rooted in the intricate physics that black holes, celestial objects with an immense gravitational pull. A black hole, in the simplest of explanations, is a space region where gravity is so powerful that it creates an inescapable vortex. Absolutely nothing, not even particles of light known as photons, can break free from its gravitational confinement. This potent gravitational pull is the catalyst for what scientists refer to as the spaghettification process. The term might sound whimsical, but it's a remarkably accurate description of a terrifyingly powerful phenomenon. The strength of a black hole's gravity isn't a random occurrence. Rather, it's directly related to its physical characteristics, specifically its mass and size. It's a simple equation. The smaller and denser the black hole, the stronger its gravitational force. Drawing nearer to the black hole means increasing the gravitational disparity between your upper and lower body. This results in a significant stretching effect. The difference in gravitational pull at various points in space is called tidal force. In the context of a black hole, the tidal force is so strong that it elongates objects into thin, lengthy strands, hence the term spaghettification. The process is relentless and inevitable. The gravitational pull of a black hole is much stronger on the side of an object closer to it than the one further away, leading to an intensifying stretch. So to summarize, if you fall into a black hole, you'll get stretched into a long, thin strand, like spaghetti. This process, known as spaghettification, is caused by the extreme gravity of a black hole, which pulls harder on the closer side of an object than the further side, creating a stretching effect. Spaghettification in black hole physics may seem like sci-fi, yet they're valid cosmic phenomena. Black holes, profound regions of space-time with extreme gravitational pull, have intrigued scientists for decades. Their characteristic of spaghettification, an object being stretched into thin, long shapes, is an exciting concept. Although direct observation of these phenomena is impossible, indirect study through their space-time distortions provides valuable insights. When considering spaghetti, don't forget to contemplate the astronomical spectacle potentially transpiring millions of light years away. Bon appetit!